We consume a fair bit of fossil fuel, such as natural gas, to keep our homes warm and to generate power. To reduce our consumption of natural gas, people are looking at a hydrogen economy, where renewable energy sources are used to produce hydrogen, and this is used as a carbon-free fuel source. I'm Kevin Dorma. Today we will explore different ways to decrease our consumption of fossil fuels by looking at production and consumption options for a hydrogen economy. Now, hydrogen reacts with water in our atmosphere to produce water and energy. And specifically, this reaction does not produce any carbon dioxide. How can we compare the overall effect of the latest methods to produce and use hydrogen to fairly standard options with natural gas? Does it matter how the hydrogen is made? Most hydrogen today is made by reforming natural gas, and in the future, we propose using electrolysis with water. And does it matter how we use the hydrogen, whether it is for heating or for vehicle fuel? Now, full disclosure, please go to my blog at kevindorma.ca for the written article and the Jupyter Notebook with all the math, and you can find it in the article, Is Hydrogen Too Valuable to Burn? And if you disagree with an assumption or with the analysis, then please write a comment below and we will begin an intellectual conversation. Let's get going. We will consider a basis of 100 gigajoules of hydrogen. And we'll begin by producing the hydrogen through steam methane reforming, which converts natural gas, or methane, into hydrogen. And this is about 75% efficient. This means we need about 133 gigajoules of natural gas to make 100 gigajoules worth of hydrogen. If we placed a steam methane reformer in our backyard, then we could utilize the abundant waste heat from this process to keep our homes warm. But that's a different topic for a different article. We're going to start by using the hydrogen to provide 100 gigajoules of heat for our homes. And 100 gigajoules is 100 gigajoules, so it doesn't matter if we burn hydrogen or natural gas, and the standard technology today is a high-efficiency gas furnace to provide the same 100 gigajoules of heat. And this requires 100 gigajoules of natural gas. Now we compare the 133 gigajoules of gas needed to make the hydrogen with steam methane reforming with the 100 gigajoules of gas that we use directly in our furnace. And from this, we see that hydrogen is a bad choice. Let's change the fuel usage. We'll consider the same 100 gigajoules of hydrogen, and instead we will use this to power a fuel cell for a vehicle. The overall efficiency of the fuel cell plus the motor is about 58%, which is pretty good. And this provides 58 gigajoules of shaft work for driving the vehicles. But we have other ways to provide 58 gigajoules of shaft work. We could use compressed natural gas and a standard gas engine, which is about 30% efficient. And this would require 198 gigajoules of natural gas. When we compare, we see that hydrogen is the winner in this case. 133 gigajoules of natural gas to produce the hydrogen compared to 198 gigajoules of natural gas to power the vehicle directly. This comes with some cautions. We need a lot more steel and concrete to build the facilities for steam methane reforming, and we need some expensive fuel cells. This option looks promising, but it may have some poor economics. Now it's time to produce our 100 gigajoules of hydrogen with electrolysis instead of steam methane reforming. Currently, the best electrolysis facilities are about 70% efficient. And to do this, we will add 143 gigajoules of renewable power to supply the energy. But here, we need to consider other options for the additional 143 gigajoules of electrical power that we have just added. Rather than producing hydrogen, let's put the power back onto the grid and back out a combined cycle gas turbine. This type of power plant is 45% efficient, and this would back out a whopping 320 gigajoules of natural gas. But we need to replace the hydrogen with natural gas that our consumers were using, which could be either for heat or for vehicle power. Now, heat is easy. We need 100 gigajoules of natural gas to match 100 gigajoules from hydrogen. And when we subtract, and we have to subtract the 320 gigajoules of natural gas that we backed out from the gas turbine. And that means we save 220 gigajoules of natural gas in this case. When we compare the best use for renewable power that we installed, we see that making hydrogen by electrolysis is a poor choice. We decrease our consumption of natural gas by simply dumping the excess electricity to the grid and backing out a fossil fuel power plant. Our other consumption option is vehicle power. And here we will again assume that we power our vehicle with compressed natural gas. And this requires 198 gigajoules of gas to provide the same shaft power as hydrogen in a fuel cell. We have an additional 198 gigajoules of natural gas that we need to consume, but we've credited 320 gigajoules by backing out the power plant, which means we save 120 gigajoules of natural gas. And again, we decrease our consumption of natural gas by simply dumping the electricity to the grid and backing out a fossil fuel power plant. Now we can fill out our table for choices in the hydrogen economy. Using a steam methane reformer to produce hydrogen, which is then used for fuel, is a bad choice. This is because burning hydrogen is not that special, and it provides no advantage over burning natural gas, and this does not make up for the inefficiency that is inherent with producing hydrogen from natural gas in the first place. On the other hand, using reformer hydrogen in a fuel cell seems to be a winner, seems to be a good choice. The high efficiency of the fuel cell compensates for the losses with reforming. Now we get to renewable energy and producing hydrogen through electrolysis. Burning this source of hydrogen in a furnace is a really poor choice because we have squandered the electricity to produce a rather small amount of combustion fuel. And this energy could be put to much better use by simply backing out the fossil fuel power plant. And using electrolysis hydrogen to power vehicles is also a bad choice. When it comes to renewable electricity, our best choice for using this energy source is to back out fossil fuel power plants. This requires no complex facilities for producing hydrogen and no change in technology for hydrogen distribution or expensive fuel cells. And when the very last fossil fuel power plant is being decommissioned, then we should use electricity to generate hydrogen for our vehicles. Those are the good and bad choices in a hydrogen economy. Take care.